failure is the way. And you are building stuff that most likely no one has built before, or at least you don't know about such cases.
Welcome to a brand new episode of our podcast, Human and AI, Mind, Machines, and the Great in the Sand.
Thanks for tuning in to our geeky podcast to discuss the fascinating field of AI and machine learning, corporate craziness, passion for technology, and the role of humans. We are Uli and Aberi, your hosts for this episode, and I want to introduce you to our today's genius mind. We have the pleasure of welcoming German Suvorov, a seasoned engineer with the skill for tackling challenging problems head-on. At Siemens, he drives business development within and beyond the NVIDIA ecosystem and is currently focusing on the industrial applications of AI. And German is also deeply involved in areas such as self-supervised computer vision, AI-assisted simulations, and language models. With a background as an AI solutions architect, German brings a wealth of experience to the table. Join us as we delve into German's journey and explore the practical aspects of working in the intersection of technology and industry. And when he's not building AI solution architectures, he likes to play jams with tech pros. But more about this in a bit. German, welcome to the show.
Hello, thank you for having me here. Excited.
Yeah, excited. So what does it actually mean you play jams with tech pros, right? Could you share a bit of a light? What's behind that? Again, everyone looks you up on LinkedIn can see already a bit of the history, right? And to be frankly fair, we're interviewing a lot of tech enthusiasts and experts, right? And we saw some correlation of music and passion for music and passion for coding seem to be a thing. Maybe it's causation is not correlation, but maybe you detangle that now. What is it about with music jams?
Music is a language. It's a way of communicating. And it's one of the most exciting languages that humans have, to my opinion. And you have verbal communication and you have non-verbal communication. And music is a concentrated non-verbal communication that is connecting people on the levels that are not really reachable in everyday talks. So I experienced jamming with other people, and it was one of the best experiences in my life. And since then, I was looking for this and also helping other people to open up and to go beyond their boundaries of communication, self-limitation, improvisation, just to learn to let go with music.
But what kind of instrument is it?
I play bass.
Bass?
I mean, I love all kinds of music. I try different instruments. I play a little bit of drums, a little bit of keys, a little bit of guitar, but my favorite choice is electric bass.
So we should have a jam session right here.
We should have. Funk is what you don't play, right? What kind of music style is it then?
I listen to funk and jazz a lot, but it's whatever happens in the moment. Like here, we're talking and we're jamming.
Yeah.
I wouldn't put any style tag on what's happening here.
And I hope this podcast is also one of the best experiences in your life. But let's see how it goes. And then you can decide.
Let's raise the bar here, right?
But so, German, you just touched upon the connection that you have to music and jams and how all of that plays together. But what about AI? When it comes to AI, where does your passion come from in the first place? Is there any, experience that you can share or a specific aspect of AI that truly inspires you and fascinates you?
I love solving problems. When I don't have a good problem to solve, I start inventing them. So to avoid this, I'm looking for the real problems to solve. And industrial space is an infinite source of problems for people who are trying to manage it. And AI is what we call AI, right? Because the AI term itself is very broad and it's ambiguous. But if we take the general understanding of AI, which is, to me, is deep learning networks based technology of modeling things. It's a great technology to solve some of the problems that appear on the manufacturing side, on the production floor.
And how comes that you're into the machine learning space? What is the passion? Are you trained? Come from math? Come from computer science? Or
Kinda. I'm a versatile engineer. I loved programming and computers from my childhood. And when I was choosing the university, I was 15 back then, and I was choosing between chemistry, biochemistry, aerospace, and IT. And I chose aerospace.
There you go.
It was hard to choose because I was interested in many things. And actually, I kind of diverted from the AI path at that moment, but it gave me an outlook, an insight into the real life problems. What is manufacturing? What is engineering? How difficult it is to really build something. And when you start to build in scale, those problems, challenges, they multiply. And there is a different kind of problem to build something in large quantities compared to something built just as a prototype. So back in 2005, I had a PhD thesis, and it was on the intersection of manufacturing, industrial automation, and data science. There was not such term as data science back then. It was big data. So we were exploring the ways how to improve manufacturing supply chains with big data analytics. So I could say that my first milestone in AI was in 2005 with this PhD thesis.
So problem solver and problem maker, is that then converting me to a problem solver, right? So if we're talking about problem solver, right? I guess industrial applications in AI specifically, right, are a great way to solve things which have an impact in real world, right, in manufacture and production and so on. If you look now at the current problems and challenges, what use cases that you actually apply and try to solve, right? What can you give us a bit of a glimpse? What are the applications you're talking about?
The application field is almost indefinite. It's like you can solve virtually almost any problem if you apply enough resources and time and effort. At the same time, some of the things are more feasible and more realistic to implement than others. And my focus is currently on computer vision. And if we would narrow it down to the things that I did and that I'm working on now, it would be defect detection and anomaly detection on production lines and packaging lines by the means of computer vision and deep learning networks. And if we would narrow it down further, it would be with edge computation. So that means not in the cloud, but very close to where your sensors are, where the process is happening. So I believe that we have enough of experience, as humanity, we have enough of experience to be able to build such systems in production. Because different parts of AI, they have different levels of maturity at the moment, and some of them can be implemented for proof of concepts. So you can do some stuff in the lab, but it's hard to apply it to the real production process and to scale. And with computer vision and defect detection and anomaly detection, we are currently at the moment where we already can get business value out of the technology, and that makes it especially interesting for me. So it's not just science, it's not just research, but it's an applicable technology that can help earn and save money and resources and time for people.
And would you then also say that, I don't know, running AI on the edge or, really doing that on the shop floor, that this is also one of the biggest advancements in the, in the AI hardware acceleration that had the biggest impact also on, the development of computer vision applications that you're seeing, or how do you see that also evolving in the upcoming years?
There are several components to that, and they all develop simultaneously. And it's kind of a critical mass that is accumulated. To name them, I would start with data. So it's hard to do data science if you don't have data, if you don't have enough data.
And good data.
And good data, yes. And that's another challenge. And data is, it's now easier to generate data, to collect data sets on the shop floor. It's easier to synthesize data. It's easier to process data as we have more tools. It's just kind of the level of maturity of technology. The second one would be computational resources. So now we have better chips, we have GPUs, we have computers that are able to work in industrial environments and provide productivity that is required for the models to run. We have the models themselves, we have the mathematical basis. So it's currently at the mature state, so you don't need to have researchers on your team to make a computer vision application that works. So technology is available almost to everyone. And there are people who are interested in that. And maybe I should have put it as a first priority thing, that the problem owners are interested in solving those problems. And there are some resources and budgets that are open for allocation in that realm, if the solution is mature enough.
But let's talk about the model and the hardware, because I think the last years have been shown that you build larger models, not larger models, then you come with specifically in computer vision application with VGGs and architectures, and though the main solution seemed to be build larger architectures and throw more GPUs on it, right?
Makes sense. Brute force.
Makes sense, right? So, but if we move now further, do we need to rethink hardware acceleration? Do we need new processing units? Do we need smaller models, larger models? What's your view on that? Right, on the craziness of model architecture, scale and compute scale.
I would say it's all very case specific. It depends on what is your limiting resource. It's in the early phases of a project, you would not be that sensitive to the hardware. So it's cheaper and it makes sense not to limit yourself with hardware too much when you're looking for the technology, when you're looking for the architecture. So it's better to have some surplus, some extra compute that you may not use than to be limited by that. So in the early stages of a project, you are looking for the solution, and you wouldn't like to try to immediately make an optimal solution. So you would like to make something that works on some range of products and processes, and then once you have made it operational, then to try to optimize it and to make it more effective and maybe more scalable, as it will require less computational resources. So if the project is already scaling, or you are going to scale it, it already works, then probably it's the right time to think about optimizing the compute.
But do we need to rethink the compute? That's if you go in 3 years further, 5 years further, maybe, right? Just adding GPUs, is that a thing? Or there are certain kinds of initiatives like neuromorphic computing, right? moving into, I think new computation paradigms, let's say, right? Old-fashioned neuromorphic, maybe, in other aspects. Or do you say like, I can't just buy, enough graphic cards and just throw it onto your problem, we'll solve it, right? Do we need to, if you want to advance in machine learning, more specifically, right? Is that
maybe?
Yeah.
But I would say that if we talk business, you need to make stuff that works, and new concepts would be too far away from reality at the moment to think too much about them for the business applications. So it's stuff for researchers, for scientists, and when they are ready, they will introduce something to business. Mm-hmm. And business-wise, it's not just scaling by buying more GPUs. GPUs themselves are advancing. So NVIDIA has a 2-year cycle, product cycle for most of their products. So that means that every 2 years we've got a more powerful GPU available commercially. And more powerful means 4 or 5 times better performance in the more or less the same form factor. So I would say the challenge here is to keep up with that, with the 2-year product introduction cycle, because you have only 2 years basically to start building something on this chip before the next chip is introduced. So we are not that much limited by compute at the moment. I would say we are more limited by data, good quality data, and people who are able to bring this stuff together. So that would be the limiting factors, the bottlenecks, not the GPU performance, to my opinion.
And this actually ties in perfectly with the next question I would have, because if we have a look at the deployment of AI models for real-time applications, and we're speaking like autonomous vehicles and robotics, and we need a very low latency but maximal throughput, and those kinds of hardware solutions. And you were just like mentioning the NVIDIA example with the chips. So how's like the hardware development also really addressing those performance requirements? Doesn't mean like we're just not there yet and we have to like wait and see how this will evolve, and what implications does that have for the AI industry?
Again, different cases require different latencies and different architectures for that. And latency comes from a variety of factors. You have a whole pipeline that creates latency. Every single step in the pipeline creates latency. Image acquisition, if we talk computer vision, has some latency. Moving those images to your device that runs the model, it has some latency. You have network latency, you have all inputs, outputs. The software itself, different architectures would have different losses, I would say, for latency in input, output, and in inference. Then you generated your output, you have some latency of delivering this output and then reacting to that. Usually some motion control technology would be involved in reacting to the stuff that you found out. So each single step creates some latency. And if we have strict requirements to reacting quickly, we would like to optimize the pipeline so that the latency is the lowest. And actually it takes a team of very diverse professionals to make it really work fast. But the good thing is, in the majority of cases, you are not that latency sensitive. So in the majority of manufacturing processes, you have enough time to react with the tools that you already have. So if we talk sub-millisecond latencies, that's kind of a special thing, and we also work on this. And you have, let's say, 100 millisecond up to 1 second range where it's pretty comfortable to work with the standard setup, standard architectures and equipment that we have. And again, depending on the process that you're working on and depending on what you're trying to achieve, sometimes we are looking not just at the technology on how to make things work as they were initially stated, but also on the process itself. Can we change something in the process that will make the technology task easier? For example, for anomaly detection, we worked on a project where we were looking at defects on the packaging. And what we found out that despite the initial request for very low latency, very low reaction time, we had almost 2 minutes to really react, to be able to stop the line before the products hit the stage where it will be too costly to move them back. So, and such requirements, you need to look into them yourself and question everything, because sometimes they may be too strict. And if you look at the process and you see that there is like a margin for easier things and simpler things, and you don't need to spend the budgets to try to create something overcomplicated that is really not needed in this exact business case.
Though I need to poke you again, so I understand that, obviously efficiency is also, you need to see the entire pipeline and you need to revise the entire business application or use case, it's not only on compute. Though if you look at a bit of the big tags and the devices and, the hardware that we're seeing, there seems to be a trend for AI-specific hardware, right? So every company thinks and rethinks about, can I produce my own chips even, right? Can I produce my own stuff, right? And that mean maybe even then tied to specific applications. So, AI task-specific chips, right? Hardware. It seems to be a bit of a trend. So everybody's like, okay, it's not only about general purpose, acceleration, but, more specific. What's your view on that, a bit on the horizon? Is it something companies, software, tech checks should invest, go and move in?
Again, it's all case specific, and in some cases it does make sense to develop and produce case specific hardware. Usually, of course, it requires large scale of operations and repeatability, and it comes with the price of you're not really too flexible if you would like to change stuff. So once you've got it in hardware, you have to change the hardware to change the application. But if you have large scale operations, that totally can make sense. It's just an Excel formula, right? You can just compare the cost of operation with the benefits you get.
Yeah, but it's an interesting transformation, I think, because the previous years were dominated that, big tech and industrial also companies, want to go in the platform business, let's say, being on infrastructure as a service whatsoever, right? And not touching or trying not to go into the hardware, right? Be as digital, be as software, be as SaaS-based business model as much as possible. And now I have the feeling I see some kinds of verticalization now, and say like, no, as a tech company or industrial company, you want to own the verticals, not the horizontals, right? I bit of get loose of the single platform biz, right? In terms of the vertical application. No, I want to own not only hardware, but I go even down there, because in the future I'll bet my thing that, I need more or less compute, probably more, right? Do I want to have maybe supply chain? I don't know, maybe securing your own compute, or maybe specific use case requirements my application brings on the table to go in this, totally, verticalization of production of compute, right? It's a bit of weird of not weird but interesting moves, right?
The whole field of AI, quote unquote, stuff is developing, right? It was immature, and now it's getting more mature, and numerous experiments were run to kind of identify stuff that works. So now, once you know what works, and once you have the market demand, you can solidify it in hardware if it makes sense economically. So for more flexible stuff, when you discover and research, still more generalized hardware would be more applicable. And everything evolves. I think there are some cases, for example, I don't know, face detection, some object detection models that are pretty robust and they are well developed, and it makes sense to use case-specific hardware for that because the cases themselves do not evolve that much. At least they evolve within the hardware product cycle, like several years. For industrial applications, I would say that is product specific. That manufacturing is a very flexible thing. So you have new materials, you have new products, you have new processes. Of course, it depends on the product and the market, but if we take manufacturing in general, you would see some flexibility on the production line. So it's not stable, and you would like to develop your model as well, the model that your AI that works on the manufacturing line or packaging line. So I think in this space, we are still looking at the more generalized hardware, like generic GPUs, and it's more cost effective to use them than to try to make your own hardware at this current moment. For these cases that I have in my mind, but yeah.
That makes a lot of sense. Like, I mean, it can also change. Like, if the use cases or the requirements also change, then it might make sense. But as you were describing it, like for now, probably you should stick with what is out there, just like cost-wise, and to meet the requirements that are needed for now.
It's just easier.
Yeah,
it's simpler. You have a lot of innovation there, so to deal with, and you don't want to overcomplicate stuff.
Yeah, and speaking of overcomplication, what you already touched upon in the beginning was like you wouldn't start by creating the perfect solution or like optimize everything from the get-go, but you would rather start like small, and then you were saying like, I don't know, like starting with the POC and then piloting and then slowly starting to optimize so we're ready to scale. And there's also quite a buzz around that. So everybody's talking about building POCs and building pilots. And I feel like you have generated so much experience in that field and have run various pilots yourself, and we're also part of like scaling solutions. We're part of avoiding the POC trap. So what are some of the biggest learnings and best practices that you can share with practitioners that are listening right now? Like what is the message that you would convey to them?
I would say the failure is a part of the way. The failure is the way, if I would rephrase the common saying. And you are building stuff that most likely no one has built before, or at least you don't know about such cases. And what you're looking for is failing fast, as Silicon Valley approach, identifying the stuff that could kill your project later down the road. Identify it and test the hypothesis early. So usually if you sit down and think, and if you try things, you will identify those limitations that are critical for the project and test them early on. That would be the general approach. And to do that, the first thing that you would like to do is to build an end-to-end solution as soon as possible. But do not try to make it good enough. Just make it quick and dirty, end-to-end. Just try dealing with problems. Get to the factory floor, collect data, look at the process with your own eyes, spend some time on the line with people, asking questions, observing things, because you will find out things that no one has written down in the project specification. And the biggest thing that you would be looking at would be variability of different kind. Variability of environment, variability of product, variability of process, of locations, light conditions, noise, whatever can affect the final solution, you would like to identify it early on. And once you try to build it end to end, you will have to dive into different aspects of your solution. That would include integration to other systems, interfaces, how your operators or whoever the user is will deal with the solution. Are you looking for an automated solution or a co-pilot for humans? Usually trying to build a fully automated complex solution would be the best way to kill the project. So you would like to start with something that works together with people and people are making decisions. So you would like to just support them in this.
So hitting the real world, as fast as possible with even a rough pipeline, right? So do you think customers and clients are ready for testing out, because it's investment, right? It's what do you mean you're not going to productive now? What do you mean it will end up failing, right? What do you mean, stuff like that? How do you have this conversation with customers and partners?
It's a very good question, and probably it's the most important question in the business of AI. As obviously and understandably, customers want stuff that works, right? So maybe the most common thing that we hear from companies is we don't want to invest in R&D. We want the solution that works.
No science projects.
Yes. And they are looking for short-term ROIs. So the normal thing would be having a positive ROI in 1 or 2 years, the normal expectation, the usual expectation. And usually people want to see out-of-the-box solutions that work. So you don't have to invest too much in research, which is possible in some cases, like more general stuff that has already available pre-trained models from NVIDIA or open sourced, or whatever source you would like to choose. But for more custom cases that are more customer and process specific, still a fair amount of research and trial and error is required. So that kind of creates a filter to what is feasible to do with AI at the moment. And the first thing I would look at would be a very strong business case. So if there is a real problem that we're trying to solve, then it makes sense to invest time and resources there. Or if the problem is not that obvious, if it can be done with available out-of-the-box pre-trained models, then it may also be feasible. I mean, if the problem is not that, what's the right word? Problematic. If
the problem is not huge enough, right?
Yes.
So sometimes it's even hard, but to calculate directly the ROI, the return on invest, or the business case for it, because it's sometimes you identify if you go end to end, right, and you're like, oh, what the fuck, right? It's a totally different problem actually we need to solve here, right? And these kinds of learnings, right, which you iterate back, and so I think it's a bit of a pitfall still. But you touched on an interesting point. What's the role of an ecosystem, and what's the role of open source, right? I think, we have big, giant, we are here in US actually, downtown California somehow, right? Big tech companies, let's say, releasing, subscription-based machine learning. And then you have entire fascinating world, ArchiveX, driving open source, open innovation aspects. What is the role of ecosystems? What's your, should every nowadays software company has its contribution to the AI open source community? Should that be the golden rule?
It seems that not all the companies are willing to use open source components in their solutions, in what they are building. So I look at it this way, that if you need to solve the problem, you are looking at the whole range of what can be used to solve the problem. Once you have an understanding and you have done tests and you have built an end-to-end pipeline that works, then you can tweak things and look at stuff that I would say from the political standpoint or from the strategical standpoint, like can we substitute this open source model with this proprietary model or the other way around, depending on what you're looking for. What will be our performance and accuracy or whatever quality parameters you use. So I've seen both open source and proprietary approaches to.
But should we contribute to the open source community? Because obviously, whatever team I'm engaging with, right? And it's like, have you tried computer vision? Yeah, we tried a bit of YOLO here, a bit of VGD there, and it's like actually that's pretty dope. And I think one of the driver, and we should somehow commit, right? There's the two sides. On the one, like we profit from it. Let's give something back to the community, right? And then there's the second aspect with regard to industrial grade, right? The paradigm between, Raspberry Pi versus controllers, right? ROS versus semantics, right? These kinds of, interface, what makes industrial grade applications, though it's still, we profit a lot from that, right? So,
from my personal perspective, of course, if you use something, it's good if you also support people who did that. So that would be fair. But sometimes in business, other aspects have priority over this simple approach. So yeah, as a human being, I would definitely say yes, business should support open source, but in the real life, in the real business context, it's not really obvious how to do that.
Yeah, the paradigm of reciprocity and how it applies if we have to move fast and we want to secure the IP. It's not an easy game to play. I'm wondering because especially also in recent years there has been an impeccable pace of AI developments, especially also in the industrial AI space, and like so many things have transformed over time. Are there any like key developments or shifts that have significantly impacted how industrial AI is like moving and transforming? Is there anything that you see there?
Yeah, of course, a lot of stuff happened, and some of the things that were taking 2 or 3 years to develop are currently available off the shelf. You can just, basically everyone on the market has access to the state-of-the-art or almost state-of-the-art, close to them, models and architectures. In the visual space, I like the anomaly detection principles and architectures that can help detect stuff that is different from normal, and it helps build applications faster, so you don't have to know what exact defects will be there. You don't have to have a large data set of defective products because it's hard to acquire. You don't have a lot of defects on the line usually, and it's hard to capture them, it's hard to label them, and if you have a data set of defective items, it does not guarantee you that the defects that will be in the future will be looking like that. So a normal detection approach it looks to be more feasible here, and variational autoencoders, transformers are kind of technologies that seem to be the right choice for anomaly detection pipelines. So that would be probably some of the most interesting findings in this field. And also, the whole thing with LLMs, I believe it contributes to development of complex engineering products. So now it's easier to work with huge amounts of data, unstructured data, and language models, they kind of act as a binding layer for everything else. So now, instead of trying to even understand large technical texts, documents, you can use LLMs to kind of
synthesize the content. So speaking of Gen AI, so what was the last thing you did with ChatGPT, or some kinds of versions?
Coming up with a design of a birthday cake for my daughter, right. To show it to the person who would be baking it. I'm not that good in drawing, so...
Okay, so you came up with a vision then as well? So yes. Coming up with the recipes and the ingredients as well?
No, not really. Okay. Just the visual part of it. She loves planes, and we wanted to make it look like a plane landing on water. So it did pretty good job.
So it seems to be, so because you're a vision guy, dude, right? So that means, a lot of FIP and hype is obviously with content synthesis, copilots, right? Having assistants, let's say, on text representation. So with GPT-4 and multimodal representation of foundation models, right? It's also, and you touched upon transformer architectures, right? Hitting anomaly detection with visions, right? So though it's still, glimpses, right? I have glimpses of, forecasting on time series, on energy, on load and grids and stuff like that. We're exploring the capabilities there. How do you see the scale in terms of using foundation models for the vision applications there? Too big to handle? Too hard to handle?
I was very skeptical.
Yeah.
I was very skeptical on the whole Gen AI topic.
Okay, why?
I did not see the real application, industrial grade application for Gen AI. It was looking like just fun thing. It's fun to make a birthday cake image, but when you sit down and think, how can I use this for my real production process, it was really hard to come up with stuff. But talking visual part of it, it's one of the applications that I recently came across. I love synthetic data. So synthetic data generation is a beautiful concept and a beautiful technology that helps launch computer vision applications way faster and cheaper than it was before that. So collecting data and processing data is a huge cost driver. Sometimes it's a blocker for the application to be developed. And generating synthetic data, I have experience with NVIDIA Omniverse in particular, and the replicator part of it, which is a platform for collaboration in 3D space, and the replicator is kind of an SDK, a module that helps you change your scene using scripts. So this way you can build your 3D scene of a production process or the product or whatever you are working with, and with scripts you can change it. So you can change the textures, the materials, the lighting, the camera position, whatever variability you want to introduce to the system. You can generate virtually unlimited data, which is perfectly labeled. And still it's a great thing. Data scientists that I worked with, when we first used synthetic data to train the model, they were blown away with the simplicity and the performance that they've got, the robustness of the model. Mm-hmm. So basically, instead of trying to collect data with your different lights positioned in different places, you just make a script that changes it all and generates data. Mm-hmm. But you still need someone who will work with those 3D models. You're a technical artist, an engineer.
Still need the simulation, right?
Yes.
Somehow, and
you still need someone who will
still
draw the pixels.
Right? Yeah.
And with Gen AI, you can create prompts that change the textures, for example. So instead of drawing the objects, you can
So you're generating your
Generate
simulation
that.
environment and adopting the environmental textures, lighting conditions, and properties via prompting instead of interacting with complex software.
Exactly.
Somehow?
Yes.
Okay.
Yeah. So this way, it's not that you can build anything with this thing, but it can simplify a huge part of it, which is very mechanical, I would say. For example, you want to introduce rusty surfaces, because when your equipment is new, you have shiny steel or whatever material you use surfaces. But you would like your computer vision system to work with the equipment that is 1 year old or 10 years old or whatever. And you would like to introduce this noise and this variability of different materials and textures. And instead of hiring an artist to draw these different kinds of rust that can build up on your metal, you can just make a text prompt and make thousands of different variations that will be good enough to train your model to be robust to this kind of thing. So that's when we came up with this thing, I started to think, hey, something is there. Gen AI is not just a
buzz.
Not
Here
just
to
a buzz,
stay.
not just a playful thing.
And what is out there? What's the next big thing when it comes to AI, from your perspective?
I believe that AI and large language models in particular can help people agree on things faster and easier. In every team, especially in a large company, you have hundreds and thousands of people with their own knowledge, with their own vision, and it's hard to synchronize them and get them going in the same direction. So I believe that using AI, you can manage knowledge more effectively and talk in the same language with every person that is involved in the process. So, of course, AI has a lot of applications, but the one that I am really interested in and the one that I believe in and the one is, to my mind, will change the way how we do things is this one. LLM-based knowledge management. I would call it team management, but it's more like a co-pilot for a creative process. And I believe engineering is a creative process. You have a lot of data, you have a lot of information that you need to soak in to make something work. And LLMs are a great tool to make it happen. It's just a great learning supporter and communication supporter. You talk one language, I talk another.
And I play music.
Yes, you play music. And we can, like LLM agent in the middle can help us communicate better. It's okay, we can talk when there are 3 of us, but what if there is 100 of us? Like we'll lose so much in communication, that stuff that is not heard, that is forgotten, that is just very difficult to understand.
Cameron, you've seen quite a bit of pieces and went seem to be quite different roads from I don't know, small companies to now bigger companies, from partnering to technology, right? If you look at a younger generation, who's trying to make a difference in the world, aspiring and thinking about going into the AI space or in the vision space or the entrepreneur space, right? What 3 advices would you give them?
Things are changing, and the pace of change, it seems that things will change faster. So it's hard for people to keep up with that. Even younger people who are designed to adapt and to learn. So I think the main thing is to do stuff that you like, that kind of brings you energy and joy in life. Because things will change, and if you spend time doing stuff that is not really fulfilling you, you might lose some precious time kind of trying to do things that didn't make sense. At least you will, if you do stuff that you like, you will spend your life more joyfully and in a more fulfilling way. At the same time, sometimes you need to do hard stuff. So learning is usually hard, and sometimes you need to invest your time and effort in making things work and learning things. And that brings me to the practical aspect. So the more experience, the more practical experience, hands-on experience you can get, the better you understand how things work. So the practical aspect would be
get your hands dirty, get the hands dirty, touch the river first, and be passionate about what you're doing. It's sometimes hard to, I think, to find something that you like, because I don't know, it took me ages to stop late. And I guess something is about being or practicing it very good and repeating it or learning it, and then suddenly it starts making fun. You know what I mean? So it's similar as Prof. G said, I think he takes the tax lawyer, right? Tax lawyer is super boring, right? But if you're really good in that, I think you can generate a passion for it, right? And it was not at the very beginning that you are, when I'm grown up, I want to be a tax lawyer, right? Stuff like that. But it's a dope thing, nothing wrong here, right? For the world outside, right? With a tax lawyer. But, it's a bit of a hard thing to say, an easy thing to find something that you're fond of, right? Or stuff like that. Because for certain pieces, you should be good in something, then it makes fun, right? Is it?
Absolutely, yeah. And that reminds me of fear. Sometimes you have fear, right? That something will not work, it's too complex, I will not understand it, I will not be able to do that. And maybe working with this fear and acting in the presence of fear is one of the valuable skills that you can get. And you hone it in very simple things. For example, I think I developed this to some extent, that I'm not afraid to dive into new stuff, because I know that when I look at it later down the road and I look back, I will see it in a different light. Stuff that was frightening, that was difficult, when you look back, you're happy that you kind of went this way and you managed to do this. And now when I have something new in front of me, I approach it with the same attitude, looking backwards. Yeah. Of course, yes, this hill looks huge, and you will lose some energy climbing it, and maybe you will not be able to do that, but let's try.
So up to new hills and new adventures. And as Steve Jobs said, you can't connect the dots looking forward. You can only connect them looking backwards. And with that, I would say we close up this session. German, it has been so much fun. Thanks for being so spontaneous, passionate, and open, and for sharing your experience with us. And we want to lead with this to our final game. It's called Authentic Autocomplete, a little bit like ChatGPT. I give you some prompts and you answer, but also in split seconds, right? So, are you ready for the final challenge?
Yes.
All right. Industrial AI is?
Fun.
Great. Siemens is?
Big.
That's a newbie here on the station.
Communication is?
A cart, but you can manage it.
Ecosystems are?
Very versatile.
And the last one is pretty challenging, but I'm sure you'll do a great job. If I could invent one rule for everyone in the world to follow, it would be?
Follow your passion.
Beautiful.
Hey, German, thanks so much for spending the time. I know you cut it out, right? This session for being between different client meetings or appointments, let's say. So really appreciate it, and I think it's fun
Thank you so much.
To connect.
I enjoyed it.
And folks out there, stay bold, committed, and open-minded, and we hear us at the next Siemens AI Lab podcast. Cheers.